Assalamualaikum and selamat sejahtera to Encik Syamsuri bin Hamid Rasidi as our lecturer in Solid Mechanic 1. Today, we are from Group 2. We'll be presenting about our group project, T9, which is bending stress in a beam. First thing first, I will be introducing my group members, which are me, Muhammad Izwan bin Sabtu, Muhammad Aizat bin Muhammad Syafi'i, next Kartik Reddy, anak lelaki Narayana Murti, Harvin Raj, anak lelaki Selva Raju, and the last one is Dana Vigneswaran, anak lelaki M. Sabha. So, these are the table of contents we are include in our slide presentation, which are theory, results, calculation, observation, discussion, and conclusion.
Hi, my name is Muhammad Aizat bin Muhammad Syafi'i, DD 2055, and I will explain about the theory of bending stress in a beam. The bending stress is zero at the beam's neutral axis, which is coincident with the centroid of the beam's cross-section. The bending stress increases linearly away from the neutral axis until the maximum values at the extreme fiber at the top and bottom of the beam. The bending moment varies over the height of the cross-section. According to the flexure formula, tau b equal to negative my over IC, where m is the bending moment at the location of interest along the beam's length, IC is the moment of inertia around the neutral axis, and y is the distance from the beam's neutral axis to the point of interest along the height of the cross-section.
So, hi, my name is Muhammad Izwan bin Sabtu. We'll be explaining about the results and the calculation. So, for the first one is the table 9.1, result for experiment 1, which are uncorrected. So, for the next is the table 9.2, which are the result for experiment 2, which is the corrected one. So, the last part of result is the table 9.3, which is the average strain readings for experiment 1. As you can see, if you want to get the strain for every bending moment, you have to calculate based on their gauge number. So, if you want to get the strain for example 70.5, you have to base on the result 9.2, table 9.2, just plus 2 plus 3 divided by 2 if you want to get that strain. Next, I will be explaining about the calculation. So A, calculate the bending moment. As you can see, based on the results given above, we are having 5 kind of weights, which are 100 until 500 Newton. I took one of it, which is 500 Newton, to calculate the moment. So, by using the moment calculation, as you can see, m minus 500 divided by 2 times the distance 0.35, and you can get 87.5 Newton meter. So next is the B, calculate the theoretical and experimental maximum stress. As you can see, they have been giving us the second moment of area and the distance from the neutral axis. So to find the experimental maximum stress by using the formula m times y divided by I. So as you can see, the maximum moment is the 87.5 times 26.25 convert to the meter and divided by the second moment of area, and you can get is 39.6 megapascal. So to find the theoretical maximum stress by using the same formula but the different y bar, which is the total length for both material minus the y bar, the neutral axis, which 38.1 minus 26.25, and we get 11.85, and you can direct calculate by using the my minus I, and you can get 17.9 megapascal.
A very good day to all of you. I'm Harvin Raj, son of Selva Raju, card metric DD 200051. So I'm here going to explain about what we observed in this experiment. Firstly, the pin on the loading frame can rotate freely by applying twisting force to it when there is no load applied on the beam. Second, the pin on the loading frame cannot be rotated when 100 Newton of load is applied on the beam. The bending moment diagram in the structure software is keep blinking when the preload of 100 Newton is turned to zero load reading by set zero control. Next, there is still a value on all the gauge numbers except for the gauge number 8, which the value of 0 after 100 Newton of preload has turned to 0 reading of load. So from this gauge number 5 has the greatest strain value of 0.7 at the load of 0 Newton. While gauge number 3 and 7 has the least value of negative 0.3 during load of 0 Newton. So next, for the gauge number 1 to 5, when both loads and bending moments are increased, the value of strain are also increased in terms of negative values, while when the load and bending moment in gauge number 6 and 9 increase, the value of strain are also increased in terms of positive values. Thank you.
Hello, my name is Karthik Reddy Analalaki Naranamurthy. My metri number is DD200068. Today I would like to present about discussion from bending moment in a beam experiment. So for the first question, from the graph of strain versus bending moment and strain versus positions, it can be determined that when the bending moment increases, the strain at various positions also increases. The bending moment is directly proportional to the strain. As long as both graphs have linear functions, both the graphs have the best fit line. They were compressed by the compressive stress. The gauge number from 1 to 5 increased the strain in negative values. Following that, the gauge number increased from 6 to 9 at positive strains as the bending moment increased due to tensile stress tension. As a consequence, the strain value will be positive or negative depends on the direction of the bending moment and whether the region is compressive or tensile. So for the second question, based on the data collected, the strain gauge reading on the opposing sides of the section were nearly identical, with the expansion of the strain value for gauge 2 and 3, which differed considerable as the bending moment increased. Because they are at the same level of position and receive the same applied load and bending moment, the strain gauge readings on the opposing sides of the section should be the same. So the reading that were not similar for gauge numbers 2 and 3 may be due to the beam deflections, which may be identified. As a result, the accuracy of the experiment may be influenced by particles in the beam that were not equally distributed or the beam was not homogeneous. Thank you.
Good morning. I'm Dana Vikneswaran from Group 2. Today going to conclude the overall experiment that we have conducted. First of all, the objective of this experiment is to study the effect of different forces on the bending stress in the beam, and the results obtained from the experiment shows that there is a linear relationships between bending stress and applied load. This thus also shows a perfect linear relationship with applied load, whereas the theoretical bending stress does not have much change in terms of value when the load is increased during the experiment. We have learned on how to measure the stress distribution across the section of a beam, and also understand the relationship between stress and strain within a structure in relation to bending loads. The experiment also have been conducted with different value of loads to acquire a precise data for the report together to get more understand the relationship between bending moment and the strain at the various number of loads. Moreover, there are several errors faced throughout the experiment, such as parallax error that cause the result not be the way they are. This can be reduced or avoided by reading the value with the correct way, by make sure the orientation of eyes placed in a straight line, and also read the lower meniscus to get more accurate measurement and to successfully achieve the main objective of this experiment. That's all from me. Thank you.
That's all from us. Thank you.